Hello everyone, we'll just have a quick introduction. I'm Niko Boskovic. I'm with FortisBC. I'm station design supervisor, 11 years with the company, and I'm in charge of all facility design for the company.
And I'm Julie MacLennan. I'm about 15 years with Spartan Controls. They're the local business partner up in the Vancouver, Canada region that supports FortisBC. And this is a presentation about how Spartan and Fortis were working together with our factory contacts to support them.
And I'm Reese, Dawes. I'm the account manager at Spartan Controls, who works with FortisBC. I've been with the company for going on 13 years now.
So this presentation is about gas distribution station design and collaboration between local business partner and gas utility company in a situation when some critical equipment will going to be used for first time. So FortisBC design team had an intensive discussion with Spartan Controls, our local business partner, and Julie and Reese participate in all phases of the project. They participate in equipment selection, sizing, and commissioning. As well, they took part in the process hazard assessment. This presentation will have two parts. First one will cover FortisBC design process, requirements and milestones of design process. As well, we'll talk about project justification, technical, physical, and environmental requirements. And also we'll go over final design. In second part, we will talk about regulator sizing, implementation, and achieved business results. Before we go to FortisBC design process, a few facts about the company. FortisBC is a natural gas and electric utility company in province of British Columbia, Canada. We are serving over 1.1 million customers. A majority of our customers are gas customers, and they're serving 1 million of gas customers. The company is fully owned by Fortis Inc. So on the map to the right, you could see area of operations for both business, electric and gas. So majority of our customer base on the gas side, over 60% is based in southwest part of the province. So that's Vancouver Island and, that's Greater Vancouver area and Vancouver Island. So this presentation will cover pit-style station design, where our majority of those stations located in Greater Vancouver area. So we have 111 of those pit-style stations. They are kind of different than above-ground installations. So we'll talk about some issues we could see in the area, because the climate in Vancouver is pretty much what we experience those days here in Minneapolis. Could be a rainy season in spring or fall, and we will talk about preventing those potential flooding for the stations. So everything starts when asset management made a request for engineering assessment, and we had a request for our Rosedale station. So site is serving 13,000 residential customers, 30 industrial commercial customers. So engineering work on the risk for the site or distribution area, and we review capacity. After capacity review, we realized that station has issue with potential growth, and as well will not be able to meet urgent installation of CNG stations for the area. So here you could see a very diversified load for the station. Station is surrounded with high-density residential on the south side, as well heavy residential load in north part. On the west side, it's industrial area with heavy industrial load. Our system capacity planning build models every year, and those information about pressure and flow or load are forwarded to engineering for station review capacity review for a station. So in this case, we review capacity for our Roswell station and provide the information that the station cannot meet required demands. And in that case, we change the status from engineering assessment to front-end engineering design. Here on the picture, you could see purple is station location, and this is rest of that is underground installations for that site. This is a snapshot from our GIS system. Like I said, once when we define that project has to go ahead, and instead of engineering assessment, it's going to be a front-end engineering design document. So we define project objectives. So we try to improve our design for this style of station and also to prevent potential flooding in the area. So we also like to have a new station generation for this type of or style of stations. We would like to correct ergonomic and safety considerations for our technicians. As well, we would like to meet all new requirements by health and safety. Of course, we would like to have a station which could meet kind of near-term demand, and also to have a room for potential expansion in the area. So those type of stations could be subject to vehicle collision, so we would like to improve protection from that potential incident. So we will also like to improve filtration and change valve technology. We would like to use double block, double piston valves instead of the plug style valves used for pit stations in the past. So after project objectives, we define project justification. So in the feed, we had all options listed with full cost estimates. We also define project risk list. In that risk list, we had all information what could be required for project scheduling and construction, and to prevent potential issues. So every time when we have new equipment in a design process, or is going to be used, or on any major capital projects, we would perform process hazard assessment. In this case, our goal was to use for this station FL regulators for a few reasons. First, we didn't have a better technology for this site. And second reason is in Vancouver area, we have major capital expansion, and we need to meet demand for future needs in situation if LNG projects going to happen in the province. So for that reason, in this major capital expansion, we would need much larger style of FL regulators, like 6, 8, and 10 inches. So we would like to have a good understanding of the technology and prepare our technicians to have proper training and to be familiar with the technology. In the process hazard assessment, use HAZOP technique, we have a list of all causes, and especially for FL regulators, so we analyze all those scenarios. So we look on, I will show only two scenarios here. One is no or low flow, and another is more or high flow. So in first scenario, we can we identify all consequences, and based on the corporate risk matrix, which is a little bit different than standard matrix used for HAZOPs. So we have a corporate risk matrix and analyze potential economical impact, safety, public relation, and so on. So we convert those values as a consensus between all stakeholders: asset management, operation, group, engineering, system capacity planning, and also at this phase we have Spartan Controls as a local business partner who provide all technical information regarding the equipment. So Score was really low on our surprise and give us green light to use FL regulators because probably, as you know, FL regulators have a tendency of failing close, and we need to change our corporate standard. That was a condition. Use FL regulator with changes in the corporate standard. On the second scenario, with more or high flow, score was higher before safeguard in place, but with safeguard in place, risk was reduced and didn't have a potential impact on corporate business, and we could use FL regulators even in this scenario. So other options in feed are to move the site. So we like to do that for a few reasons. Location of the station was on very busy intersection. So we also like to update the technology of the regulators and design. Already mentioned that would be 6th generation of our pit-style station design. And we would like to have additional capacity to meet our customers' demand. And also in that feed, we work on the risk assessment. So we assessed operational risk of single point of failure is 1.3 million. That's based on the potential outages, and we call it relighting, and also with loss of business, and also cost of PR and all other associated costs. So comparing that risk to new site installation, which was estimated 850,000, so obviously it was wise to go with the project and install new station. So here is location of the old station. You could see a very busy 6-lane road, and this is control box of the pit station, and station is kind of below grade here. So when we decide to move site, we mobilize our property services. They had intensive discussion with our customers or neighbors in the area, and we've been able to find a new station location, which is between those trees and the car. And on the picture to the right, that's somewhere here, and the existing site, it's somewhere there close to the road. In this case, new location was on the flat area and also relatively close to the pipeline, high pressure pipeline, which was somewhere in this area here, if we extend the picture. Other options in feeds are to take in consideration all regulator technology or all regulator styles. So for option A, we have boot style or flexible element regulators, and for that style we would need 6 or 8, depends on the station piping size and also downstream pipe. So for option B, we would have axial 2-path flow regulators, and required size for that option was 4 inches, and also that size was available. For option C, spring to open 2-path regulators, we would need 6 inches. So we select option B for a few reasons. First reason is easy HSO style, which is option C, wasn't available at time of construction or installation. So, and that option or that type of regulator will be available around this time. So option B also was selected for already mentioned those reasons to get familiar with technology and also to provide all required training to our technicians. So changes in our standard. We need to make major change to allow all regulator style to be available for installations, but under one condition. Axial 2-path style regulators can be used only if they are in the looped system. So that was a compromise within the stakeholders in the company, and we cannot use that type of regulators if we have standalone station. Every time when we perform design or equipment sizing or station capacity review, we got this form filled from system capacity planning. And also in the project closing process, this form is required to be filled by engineering at the bottom. And for this site, you could see after system improvement, after a new station installation, so for single run, station will operate at 73% capacity. For double run, would be at 39%. So how we review our station capacity? We have a custom-built software developed specifically for FortisBC about 3 years ago. Now that software is widely available for other utility companies if they're looking to use it. So we would create a model of piping and each equipment used in the design. And also we will create a regulator database. In this case, we create one for Fisher FL SR2 regulators for both runs. And we would calculate station capacity. So I would stop here. That would be all for first part. And Julie will continue with regulator sizing, implementation, and achieved business results. Thank you.
There we go. I'm just a wee bit shorter. So moving into looking at the problem that was scoped out by Fortis, we moved into the technical solution as to what are we going to do for this. We want to consider first and foremost safety, so we looked at the system protection, looking at all the different options available for methods of overpressure protection. It was decided upon to go with the monitor solution, mostly for its no bleed environmentally friendly method of overpressure protection. Then there's other things that we had to look at with the technical design, because it's not just what you're going to do with the product, how do we protect the pipeline, but what are we going to do for the technicians? What are we going to look at for their safety? How do we protect the environment, and how do we keep this whole thing together? So the ergonomics, first and foremost, for the technician safety, always at the utmost of importance. These are buried pit designs. They're confined space, so there's a lot of issues that go with confined space entry. The reason that we opted to go towards the confined space buried design instead of keeping it above grade is mostly for tampering and hiding from the general public. No one wants the pipelines in their face. It's a much smaller land print that you actually have to put there. And no one really knows they're there. Once they grow up around them, nobody knows that the infrastructure is there, and it just happily supports them, keeps their hot water hot, without them knowing that it's even in the ground. The other considerations is when that is underground, what do we have to do for the ergonomics and the serviceability for the technicians so that they can look after it for the long term in a safe and manageable way. And then keeping in mind the environmental concerns that go with that. So we're looking for no bleed, not low bleed, not low bleed, not relief, but what are we going to do for no bleed? How do I keep that gas in the pipeline? That gas is the product. We don't want it to go to the atmosphere. We want to protect both the environment and we want to save the product. It saves Fortis money. And then because we live in a rainforest, we're just north of Seattle, as you might know, so we have a lot of rain and a lot of geographical issues that arise in an area like that where we are physically located. So robustness below grade, as well as considerations for the massive amounts of rain that we get, floods are a real concern. And this is quite close to one of our major rivers, so that's a very real possibility. So it's of utmost importance that we can operate completely underwater and still keep the system safe and protected. Then, as you can see from the pictures that we looked at earlier, there's a lot of houses around there. And nobody likes to listen to gas in the middle of winter sounding like a jet engine just outside their bedroom window. So social license and working within the residential areas drastically changes the noise requirements that you might otherwise have in an industrial setting. And that's something that gas utilities in every city and every place across the world that has gas has to take into account. The closer you are to people sleeping, the more issues you can have with the public that surround it. And then functionally and operationally, what do we need to do for that set to make it the most reliable thing? Because basically you want this to be a set it and forget it, right? We don't want to go back in that pit if we don't have to. So we looked at everything from front to back in this. So we looked at the filters, we looked at the isolation valves. So one of the things that has been prevalent in the gas industry is little plug valves. They're small and economic. There's two things that Fortis had realized in some of their predecessor designs. One, that the double block and bleed isolation valves were giving them better shutoff, and some of the features of the double block and bleed API ball valve provided better long-term functionality for sealing, as well as the DPE or dual piston effect seats. So that's become integral as a move forward to make it more reliable so that they don't have to try and drop out their manual isolation valve, because that's the thing that they use to do the other maintenance. So taking out the manual isolation valve can be a big deal. Then looking at what we wanted it to do for its job as the set it and forget it, is we wanted this to be high accuracy. We need robust, high turn down, great shifts in demand both throughout the day and throughout the seasons, and a huge amount of capacity. So this area is growing. It's all sorts of residential, high-rise residential customers coming in, as well as the large industrial loads down on the river, are really making a need for increased capacity. And we don't want to have to go changing this thing out all the time. So we're going to put in something that can give us long-term usability and a high rangeability for the application. And then most importantly, we want it to be really reliable. So we're doing high pressure cut gas drops. That's got a lot of energy and noise associated with it. We want something that's really reliable, because we don't want our technicians having to climb into the confined space to work on this thing in the first place. So that's a big consideration, and the higher your flows get and the more noise and energy you're creating, the harder that is to do. So we're looking for a solution that's really going to take that into consideration. And then one of the things that's related to that is really updating those company standards to make sure that we're looking and incorporating all of the technologies that are available in the current day world to make sure that Fortis, to assist Fortis in helping them to stay modern with the technologies and move forward so that they can use the most robust design that they desire, and it's safe and fully considered for their customers. So moving into the product, the FL was the decision. That is a two-path control regulator. What that means is you're going to have extremely fast response time and very high accuracy, as well as the large capacity via its axial body design. They're extremely reliable. Your diaphragms, your measuring elements, are not in the flow path, so you don't have a lot of energy across the measuring element. And taking out your measuring element is a big deal, so we don't want to do that. We're completely no bleed to the atmosphere, which was one of our big environmental considerations. And then in order to bring this above grade, and I'll explain why we wanted part of the station to be above grade, is the customization of the control of the piloting system that controls these regulators. The flexibility that we were able to do in the customization with the FLs allowed us to do that unique design for the above grade installation. Coupled with that is the local support, because once you've got the stuff in the ground, you need to look after it for its lifespan in the ground. And Spartan Controls is located literally 15 minutes from this site and 10 minutes from Fortis's main operations center. So that's a big deal, right? We're there. We can support them, we can train the technicians can call me, they can come see me, then they can go out to the site, I can go to the site. There's lots of stuff there to support that. And then, of course, for the technicians, the ergonomic serviceability, and we'll take a look at that in more detail. So we ran the sizing and discovered that because of the axial design, we were able to actually fit this into a much smaller overall package, which means we didn't need to look for as much real estate. And anyone who's seen any sort of house prices in Seattle or Vancouver, they're not cheap. So real estate values of trying to find space to put these types of equipment is a big consideration. So the smaller package we can fit that into, the better off we can be in the long term as the most economic package. Looking at the product itself, there's a couple features that were of benefit for the design itself. The FL has a lot of noise attenuation capability. It's got the SR2 noise abatement trim. It's a drilled hole cage. We'll look at it a little bit later, but that was a big selling factor, and it's because of that noise, right? We don't want those neighbors complaining to us or having to dump mattresses or mufflers or anything on the site in the middle of the winter so they can sleep through the night. For lockup, so one of the things we want this to do is shut off. So Fort Fisher has come out with a new seat design, the polyurethane seat design, which really allows a really robust shut-off capabilities while taking these high-pressure cuts. And the third part is because of the high-pressure cut, installing it with an SA2 pre-pilot has allowed for rock-steady accuracy. And we want to be able to respond to whatever that distributed system needs to do all the time, every time. So looking at the noise a little bit lower, or a little bit closer, you'll see here, this is the SR2 trim. It fits right in the body here. So you don't see it, it's part of the flow path, it's drilled hole, it's splitting up that gas flow to allow for a lot of noise abatement, separating out that noise and making a bunch of small little paths. And then the FL, although we didn't need it for this particular installation, some of the even higher pressure drop applications utilize this SR2. You can see in the graph here, with the SR2, you can get up to 30 dBA on a logarithmic scale of noise reduction with the combination of those two without losing much of that capacity. If this was in an alternate style, such as a boot style, this would probably be an 8-inch line. So trying to fit 8-inch line versus your infrastructure for a 4-inch line set is a huge cost saving right there on its own, just from the piping and isolation valves and equipment that go with it. So then we looked at how do we get this into an above and below grade customized solution. So we had to take the operation of that monitor configuration. So you can see here, it looks like a lot of tubes. They're all color-coded here. It's just showing what's downstream, what's upstream, and that kind of thing. But this is our monitor. It's completely buried and sensing this pressure underneath the ground. And then we had to take a look at the schematic and say, where can we split these lines off to bring them above grade? And the reason we want to bring that above grade is when we bring that above grade, the technicians, so in main and monitor when we're running parallel runs, they switch the runs so that they're alternating which one's controlling at any given time so that they get equal wear across the runs. Before, the technicians used to have to crawl into these old set designs and try and fiddle with this, and they would have to have multiple people on site for safety and that kind of thing. So now a technician can literally walk up to this, tweak the set points, check them with his gauges, close the front panel and walk away. It's now a single man job instead of multiple guys. We're now above grade. We don't have any of those safety considerations, and we're still in a nice small package on below grade. So the piping height was adjusted so that we're working more at a high level. The lower below grade you go, if you've got big, tall regulators, they end up sinking down lower than the technician can comfortably work on them. Because of the short overall height package of this, we were able to raise the piping grade level for the technicians so they're able to work at a nice reasonable height without putting themselves in physical strain. And then the other neat thing, so back in the day there was some axial designs and technicians used to always say, I don't want that thing in my line because I have to lift it out and I have to get it out of the pit, and there's all a bunch of stuff that goes with that. What they've done with this newer product is dropped in this spacer piece. So what they do is, you can see it's flange, it's a wafer design spool piece. We pop off the top set of bolts, leave the bottom ones in place, and we pull this whole spacer out, undo the bolts around the edge here, slide this piece along these lower bolts that we left on, and we have access to our seat and disc, which is the thing that will fail first if there's debris that comes through the line. That's where you lose your lockup, and that's number one, the most common type of maintenance that's done on this product. And because this piece here is our measuring element, and this is not in the flow path, this thing will almost never need a diaphragm replacement. It's not in the flow path, it's not doing anything but flexing a half an inch for its lifetime. This will almost never have to come out except to replace that seat piece. So you can see right there that the technicians have a way easier package to work on physically in the pit, and because it is two-path design, it's not going to require a lot of maintenance. The biggest problem for this set will probably be them remembering how to work on it after the initial startup, because it's going to have been so long since they last worked on it. So then we went into how do we physically get the tubing set up so that we can get this package above grade. So this is our above grade panel, and it's coming down below grade to a panel right here where we've terminated all the tubing. The tubing here is running in flexible pressurized hose up to this box here. And the other interesting thing is here's your monitor. This is your overpressure protection. We're running all of this tubing directly into the pipeline. So we're in a nice stable spot. Anyone who's ever put a pressure transmitter in knows you got to put it in a nice stable spot or you don't get a very good pressure. Same goes for regulators. They're really a self-contained control system. So we need to control our gain. We need to make sure that we're controlling our bleed and speed of response. And we need to make sure that we're sensing our pressure in a nice stable spot. All the same things that we would have whether this is an electrical system or a fully pneumatic system. And for an extra step, this is an actual Fortis drawing of the customized buried above below grade set design. And one of the interesting things that they did is they actually color coded the different tubes to the operational schematic so that the technicians could make sure that they terminated them all. And they actually color coded, put codes on the tubes so that when they were looking at the operational schematic, they could remember which tubes were which when they came back to it years later. So so if they ever pull up the drawings, it's all right there and correlates back to each other. And then it's the other thing that they incorporated into the set is a little orifice plate for a little bit of information back as to what the flow is actually doing at that station. In the old days, they used to have some digital or some pressure recorder charts that the technicians would pick up and bring back, and the engineering group would look at in the long term to figure out how to move forward from there. They also did both the instrumentation and the piping lines all on the PNID so that they could tell how everything worked out. It incorporated that color coding into the system. And then they used this as part of the technician training and did a full session with operations before it even went in to make sure they could still perform all of their checks and there was no alterations to the technician's current process, because we also have to look at their job function. If we put in this great product but don't work with them to figure out how to make it run in the long term, it's not going to be a success for them. So we had to figure out that process of checking and working with the technicians to make sure that was taken into account too. And they were quite happy with the design. They said it was really easy to follow the way that Fortis's engineering group and myself had worked with them to incorporate that in. So then what does that look like in the real world? So we take this we've had all this feedback from the field over the years. We're moving into this new product design because we're saying, hey, we heard you. Let's incorporate some of this. So one of the things is that confined space requirement. 3 things that were worked into the set design to both adhere to our OSHA requirements up in Canada, which is our equivalent of WCB, is hydraulic arms for this really heavy lid. It's a safety thing, right? We don't want that lid coming back down on them. We don't want them having to lift it, so it's all hydraulically lifted so that they can get in there easily. Greatly improved accuracy. In all of the sets that are going underground, they either have ladders or steps, so that the technicians can get in and out very easily, quickly, if there's ever an emergency, for their own safety. And the third thing that is an absolute requirement is the davit arm lift, so that if a technician does ever have something happen to them, that they can be lifted out of that vault. So the next thing we were going to talk about is that flooding and excessive rain that we get in Vancouver through 6 months of the year in our spring and our fall. So with the rain, it's a problem, right? Like anyone who's seen Seattle, they know it's rainy. One of the things we did is in the event of a flood, should that river come up or rain get excessive, we've capped the sense line. So all regulators need registration to atmospheric pressure in order to operate. And because they need to register atmospheric pressure, we ran that up into a tube so that if that pit should flood, there's going to be a pocket of air that's relatively atmospheric that will continue to allow that regulator to operate whether it's completely buried or not, and that is the only part that regulator has open to the atmosphere. Everything else is completely sealed and contained within the device. So this station could completely flood, and the overpressure protection on this will stay completely intact. The other thing that we did, a lot of the old set designs were just boxes with lids coming down on top of them. You can see here that there's a much wider lip on this box. They recontoured, the group doing the fabrication on the box, they recontoured that whole edge of the lip to promote channels to keep the water out as much as possible. So only in the event of basically a river flood would this actually flood in the first place. In the excessive rain, there's no way with the new lip design that they did on these sets that it would combine or start to flow over unless there's actually a flood in the area. And the other thing that sometimes does come in cold places like this as well is when you get the rain and then it freezes, getting that water out of that lip so that they can actually get the box open, super important. Technicians have had a lot of problems getting some of the lids open so that if there's an emergency, what do you do when it's frozen shut, right? Start blowtorching it. So then looking at the package, you can see here an 8-inch pipe design with the space that we had versus a 4-inch pipe. The lay length of all those face-to-faces and the extra equipment that has to go in with that is a lot smaller. So we were able to incorporate that package in, completely serviceable at a nice height level for the technicians. Everything's accessible. You can see, whoa, wrong button. You can see here that all of the components to work on are right at height level, right out in the alleyway for the technicians to work on. And then because we found the wider right-of-way, we were able to fit that space in. You can see there's a lot of nice space out in here for the equipment to fit in. They have accessible parking to park safely and work on this set without putting themselves in danger right on that corner of that 6-lane road. And then this is the interesting part, the above grade accessibility. So here's the 2 controllers. For most of the work that the technicians need to do, they can run their tests from these controllers. There's a few false sensing ports that they can put in extra pressure and run all of their functional tests from above grade. They only go in there if there's a problem and they think they need to do maintenance, is the only time they would even go into the confined space. So that's a huge time savings right there. And then this is the interesting part. They've gone to a modular cellular communication back into their SCADA or their gas control, so they're getting instantaneous or fairly frequent pressure and or pressure flow measurements back into their gas control so that they no longer require a technician to go out every 6 months or a year, pick up the pressure recorder, bring it back in and have it looked at a year or 2 from now. So there's a huge instantaneous amount of information. As we're talking about trying to get that information back into the system, that's the other thing that they've incorporated into the station. So everything's right there for those technicians. And then because they probably won't have to work on this very frequently, we actually put the operational schematic on magnets and a laminated copy right on the side of the door. So if they do have to come out to this 10 years from now at 2 o'clock in the morning for something, all the information that they're really going to need for the troubleshooting is right there, and they can look at it. And as I said, it's all color-coded and mapped to the station in the real world. So they're all tagged with their tubing colors according to that color schematic that's on the top there. So the technicians were really happy with that design. So we've realized this is the 6th generation of the buried pit design, and the technicians were super happy that we realized the design improvements that they had been looking for a long time. So we put in really good filtration on the pilot lines because pilots have really small orifices and tend to plug. We improved the filtration on the upstream on its own, the actual dust pot or filtration method on the upstream, because we're using that monitor overpressure protection so that we can protect the environment. And the more healthy we can keep that station and the equipment, the better off both the regulating and the overpressure protection equipment are. A big thing that we did for improved stability was we separated out those sense and bleed lines. Separating out those sense and bleed lines allow the station to go in almost anywhere, and because they're both in really stable spots and not interfering with each other, you're going to have rock solid operation all the time. Some stations will work when you bring the bleed and sense together in most stations, but every once in a while you'll hit stations where they hit system harmonics, the gain's too high, it's not quite working right, it needs to respond too quickly, and it'll go unstable, and the technicians will never be able to figure out why it's working at these 3 stations and not this one. The monitor is underground. We're protecting it from vehicles and accidents. We have accessibility to the above ground stuff where we need it to, but we're protecting it from vehicles, tampering, that kind of thing. We've taken into account the flooding and the geographical concerns that existed in the area. We've got better access spacing, safety. There's a bunch of really good stuff there. The technicians were super happy with what they were going to have to support in the field. So that's giving you a little bit of a difference. That's what they used to have to climb into and try and maintain, pull apart, and here's where they would have to climb into the vaults to do the pilot changes. And you can see why that would be a multi-person job, not a lot of room to work, and cause them a lot of problems. And I don't know if you can see it well, but this is completely flooded, about a foot of water. So they would literally have to stand there in a foot of water trying to maintain this old product. There's a lot of things that could be improved. You could see why the technicians were looking for improvements on some of the stuff. There's the new design. Easy to work on, easy to get in and out of, much safer for them, which I think is probably the big take home, and will work in the long term a lot more reliably for both engineering and serving the customer as well as for the technicians. So what did we get out of this? We executed the project on a very short timeline on time, which is anyone who does projects, a great thing. Confined space, ergonomics, and safety goals were all met for Fortis, which safety is a big goal for Fortis. It's their primary focus is safety. We reduced the operational and financial outage risk by 1.3 million per outage. And this was recognized as an underserved area where they were expecting outages in the wintertime when the loads get heavy. So that's a lot of money, because that could happen multiple times. So if you're not keeping up with the capacity, that's a big risk to them. And the savings with just this one installation of preventing that kind of outage is a big deal. The environmental stewardship, so we're not bleeding to the atmosphere. We've taken a lot of environmental concerns into account. The commissioning and startup was supported, it was executed seamlessly. We were on site there to support it, but actually didn't need to do anything. The technicians were fully comfortable with the product, walked up. They had already walked through their procedures and figured out their side of it, walked up, turned it on, and it was great. And a heck of a lot quieter than what they've had in the past. The station was operational for the winter of 2016. So Fortis fast-tracked the project and actually managed to get it in place before the winter so that they never had any of those possible outages that they might have had, which is a huge savings to them, obviously. And we had a really good team approach to engineering this station. Because it was fast-tracked, it was important to have good cohesive teamwork between the engineering and engineering operations and asset management groups at Fortis, Spartan Controls, their supporters, as well as the factory people that were helping us support this down at our factory headquartered in McKinney out of the Emerson Regulator Technologies Division. So Fortis identified that project. They worked it through its system, including safety, standards upgrades, a whole bunch of really good things. What they did was they improved their integrity of their system and took a huge risk out of their operational. Risk mitigation is of utmost importance when working as a distribution utility. So they reduced that risk by 1.3 million, and all of the technical requirements were met, implemented with a single high-performance, self-contained regulator station, completely no bleed, reducing the system complexity and working within the project constraints and geographical requirements. So for any additional information on FortisBC, there's a couple of websites here available in the presentation, both on Fortis and their information about their gas distribution. There's the Emerson Regulator Technologies website for the product information. You can contact myself or Reese, Dawes at Spartan Controls, or any of your local Emerson local business partners would be able to help you with this type of thing. Any questions? Excellent. Oh, yeah.
How did you, I saw the data sheet, but how did you calculate that future demand and helping to size the piping and things with the residential and the manufacturing in that area?
So we have system capacity planning group who is taking care of all those future demands. So every year they build the models, so they know how each customer spend in energy or consume energy. And they prorate those models with design condition, with the temperature. So in each area, once in 10 years, they must get accuracy of those forecasts. So we call it labs, load analysis, pressure testing. And in that case, they will know accuracy of their models. And also we check those accuracy during the operational inquiries. So they provide information, they prorate their models with the temperature expected, and usually those temperatures are within a few degrees. And also marketing group communicate, they know what's the development in the area. So in this case, it was a CNG station. Those industrial customers, they are not easy to prevent how often they're gonna come. And now with all those energy incentives in BC, British Columbia, so government subsidized some of those developments like CNG stations, compressed natural gas stations. And we just try to meet those demands because in the last few years, we have 18 of those CNG stations. It was just business opportunity for company.
So that's like a lot of truck refueling CNG stations. Then a lot of our fleets in the area have moved over. Any other questions?
Have you installed more of these designs?
Yes, yeah. I mentioned that capital expansion, like major system upgrade, we're gonna have 6 of those stations installed.
Yeah.
And now we have 111 total. And if you take in consideration 25, 30 years lifetime, so we usually about 4 to 5 new projects or new installs we have per year. Yeah. And this year we have also 4 of those.
Yeah, and there was actually a second one right after this that went in about 3 months after. So they did 2 in 2016 and another 6 this year.
Yeah. Thank you.
Any other questions? Awesome. Thanks for having us, guys.